Hi there, this is my little Lima shunt engine which I've had for a long time and which owes me nothing, but which unfortunately has packed up and stopped working. I was just trying to use it on my time delay circuits as an example, but it didn't want to work. So I pulled it in pieces, I took the two screws out of the bottom, took this part out. There's a couple of weights in there, I'm not too sure which way around they should be. But anyway, there's the weights to hold it down against the track. The mechanism then, the motor just comes out, and I've put that onto this stand here. Want to look at actually how it works, so if we move in a bit closer, hopefully we're going to see it in all its entirety. This of course is an end gauge, so it's very small, and they've done, I think, really well to be able to get it onto this size. So what have we got? Well, we have the wheels made of brass, which is very nice, and they in turn have metal axles, and the metal axles then are part of the way that the electricity gets from the track through the wheels into the motor. These two at the bottom then, so that it can get over points, we want the pickup to be both ends, and therefore that picks up the current from the track, and this picks up the current from the track. That had me fooled at first, because I thought, well, why doesn't it short circuit? But if we look at it, then what we can see, the wheels at this side have got like plastic bushes on them, so they don't actually contact with the metal shaft, which is in contact with the wheels at the other side. So this outer part is insulated from the axle. To get the electricity from the outer part, then we have a couple of spring loaded bits of brass, and they then push against the wheel, pushing the wheel outwards. On the bottom, the piece of pushes up against the axle at each end, so the wheels are live from one side and live from the other side, but not connected together. How does the power get from the wheels to the, well, from the motor to the wheels? Well, here we have the motor inside here with a small pinion on it. That small pinion operates this gear wheel here, which is very worn, so maybe I ought to put a new shaft on there, and maybe that's the reason it's not working as well as I would like it to. On the other side of this large gear then there is a small pinion, and that drives these two wheels, these two gears, idler gears, which then drive the gears at the back of the wheels. So they go through onto these gears, and that's how it gets the energy from the motor into the wheels. If we look at the springs again, then this spring at this side, which touches on the insulated wheels, goes up to this end, and if we look at the other end, then we've got this part here. Here's the spring here, comes through here, and then goes up through this spring, through this piece of copper here, into the, what's happening, come on, into this end here. So the electricity's got from the wheels to these two ends. From these two ends it has to get into the motor. To do that it goes through these springs. This spring then comes through and touches on the top of this brush, and this spring comes through and touches the top of this brush. These brushes then push down onto a disc which has got copper on it. Here's an example of one. This is actually a Meccano one, but the principle's the same, only on the back of here it's divided into three parts. This has got copper on it, but it isn't divided into three, but that's the principle. It pushes against here, does the brush, and that rotates, so here it's not touching anything, here it's touching the copper, here not touching anything. The brushes on the motor then are just divided into three. Hopefully we'll be able to see that. What's happened here is originally this side here was solid like this side, so I've cut it away so that I can see the disc underneath. And if I rotate the motor very carefully, come on, you can do it, try on the gear wheel, there we are, oops, just missed it there. Hopefully here we can see that across here there's copper here at this side, a gap, and then copper at that side. So we sort of have three segments. It's as if it was a cake cut into three pieces with a cut across here, and a cut across here. So the brushes then push on to one of these segments, transferring the electricity onto the rotating part of the motor. This is called the commutator. And on most motors, if I can find one, then the commutator is parallel with the shaft as opposed to being at right angles as it is on this motor. This way they save a lot of space because this takes up quite a bit of space. And on this one, instead of having brushes pushing against it at a right angle, it pushes in line with the shaft. So there we can see hopefully the brushes pushing against the bits of the copper, the commutator, so that the electricity from the non-moving part can get into the moving part. So inside the train motor we'll have coils of wire like on here, wrapped onto steel plates in pieces to try and stop what are called eddy currents. They use separate pieces of soft iron to magnetize and reduce the amount of things called eddy currents, which would heat the motor up. So yeah, that's how it works. Well, where do we find our problems? Well, to find my problems I use my trusty multimeter, which hopefully, maybe I can't, maybe I can. There we can see this then is set on the ohm scale, well actually on the continuity scale, so I can check to make sure, for example, that this slider here is in connection with my wheel. There it makes it so. I can check that this is in contact with here, or in fact check that the wheel is in contact there, and then check that the wheel gets all the way across to the brush here. Obviously if it doesn't get through, there must be something wrong. It could be the spring at the back of the wheels isn't contacting the wheel, or maybe the spring here isn't making a good contact, but it certainly comes all the way through. I can do the other thing on the other side. I could do the same thing on the other side, checking that it gets from the other wheel to here, or even do it from the axle. I should be able to check from the axle in the center there, and that is actually coming to this side. I can also check across here that my motor is working, because I get a current through the coils of wire, and that then makes the motor work. So that's all seems to be okay at the moment. I have to go through and check where the problems are, if there are problems, but I managed to do that, managed to get all the thing working, putting my little copper discs on top of the motor, on top of the brushes, sorry, has made it so that it seems to work, if that was the problem. So if I want to try to get it to work, if I bring my trusty power supply in, it isn't very good because it's flashes a bit, but hopefully we can see I've got about 5.2 volts, and I've got a couple of probes from, I've got to be careful of course they don't touch each other, just a couple of bits of brass, and I must make sure that I don't touch wheels on the same side because it'll short the power supply out. am I going to be able to do this so you can actually see both the motor and the power supply. If I come down here, must make sure wheel at one side and wheel at the other side. So how am I going to do it? Come in here, touch that one against there, and that one against there. And if I could get my hand out the way, you can see that now the motor's actually working. Touching those two wheels, touching those two wheels, and touching these two. I've no faith that this will continue for any length of time, but it's always worth a risk. You can see that this wheel at this side is really bad, it's wonky, and that's because I've had to stick it back on with a bit of super glue, so hopefully that won't affect it too much. So yeah, I seem to have got this working again, but as I say, I wouldn't guarantee it's going to last for a long time. What I would like to be able to do is to put one of these little lock motors. I think that should fit into the engine, although I'm not too bothered, I suppose, about the body. I'm more interested in the electronics, but I should be able to get that into there. And to get that into there, then I've got to get it so that this output shaft here can get onto the wheels, onto the gear wheels that will drive that. So I've no idea how I would do it, but that's a future project. Something to think about so that I could build my own little chassis and not have to worry about replacing brushes and things on these commercial one. Yeah, it's been an exciting journey. I'm glad I've got it working at the end. As I say, well, it might last, it might not. But anyway, I've got there and I'm chuffed. So that's it. So it's bye now. Bye.